Hello, everyone, and welcome to today's SANS webcast, Mitigate Access Risk by Enforcing Least Privilege in Cloud Infrastructure, sponsored by Ermetic. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speakers are Arik Gumanowski, Chief Business Officer and co-founder at Ermetic, and Dave Shackelford, SANS Analyst, Instructor, and Course Author. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Dave.
Hey, thanks, Carol, and thanks to everybody who's joined us today. It's my privilege to be here, joined by the folks from Ermetic, who have a really interesting view on what I consider one of the biggest problems in the world of cloud security today. For those of you that don't know, I'm one of the cloud instructors at SANS. I do a lot of research and sort of work in the space of cloud security, and have been doing so for probably the past 10 years plus. And I will say unequivocally that the biggest consistent issue that we tend to see rising up over and over and over again is this sort of problem around creating and managing enforcement mechanisms for privilege use within the cloud environments. And there's a lot of reasons for that, right? I think especially for those of you that might be a little bit newer to the realm of cloud security or who haven't really gotten that far down in the weeds on what's running there and how it's operating and how those sort of functional relationships between assets and users and everything else comes together. This is something that we've really been starting to tackle more aggressively in the security community, but it seems to consistently still be an issue. And I have some definitive thoughts on exactly why that is. So without further ado, let's jump right into things. And again, I'm going to kind of kick us off and talk a little bit about the landscape of what's happening out there and sort of the nature of just, dealing with cloud privileges and what that represents. And then I'm going to be handing things off to Arik because those guys are doing some really cool and interesting research as well and have seen this in a number of different ways. So I think you're going to get a lot of great information out of today's webcast for sure. So let me go ahead and jump right in and kind of lead off with my general introduction of things. And there's so many different reports that are starting to kind of come out of the woodwork about cloud security and about just breaches and security issues and trends and so forth. I mean, it's almost overwhelming, and I'm sure some of you guys resemble that remark because you just try to keep up. And of course, I think some of us that have been around for a bit, we kind of know in general the kinds of things we are consistently seeing. And I always kind of joke many times in these webcasts that it feels to some degree like Groundhog Day, because things just keep coming back. It feels like some of these problems, just even though we're acknowledging them, haven't been addressed or haven't necessarily been solved in one way, shape, or form. And I think what we're seeing are some very big trends that unfortunately are, while well known and at least acknowledged today, very much still kind of out there and in need of some solutions and capabilities that can help. And I would say, number one, we're seeing a lot more emphasis on cloud. And if you go back to look at the 2020 Verizon Data Breach Investigations report, and I quote those guys somewhat regularly, just like tons of people do. I mean, it's just an awesome very data-centric report, and those guys do a nice job at it. But I look at that as kind of a litmus test for what's happening out there, and especially since it's a broad, internationally scoped report. Those guys get a lot of feedback from different law enforcement teams and investigative groups and teams all over the world. I think it's at least a reasonable approximation of what's likely going on. And one thing that they have called out explicitly in their most recent report is just this, kind of real, kind of snowballing trend of cloud-based attacks and cloud-related attacks and incidents. And one of the things that, they didn't really drill into, I mean, they kind of cursorily touched upon it, but they really didn't drill down into the specifics, is kind of why that's happening. And I definitely have some thoughts about this. Number one, cloud sprawl. So let's face it, cloud starts one way and never stays that way. And so a lot of times cloud-based implementations tend to start somewhat organically. Somebody, stood something up in the cloud. They decided to, spin up some different cloud workloads. They decided to go deploy some, kind of mock application test scenarios, what have you. And then the next thing you know, you're fully running in cloud and there's production assets there. That tends to happen very often. It also is not uncommon whatsoever to find in especially big organizations that, number one, that happens fast, and number two, more than likely, while you're out, desperately trying to get your arms around things in AWS, the sales team from Microsoft is taking your engineers to lunch, and now you're in Azure too. And so now you've got these multi-cloud deployments that you've really got a whole sprawl going on in, but it's still workloads and assets and all these, sort of related pieces. And when you start breaking down the sort of base elements of that, there's thousands, especially, in big environments, there's thousands of things like asset identities, and might even be, again, in especially big organizations, millions of privilege-related entitlements that are relating systems to one another, things like service accounts into those infrastructure elements, from one service within the cloud provider environment to another service. The list goes on, but here's what I always kind of boil it all down to. Everything in the cloud has an identity, period, whether it's a service or whether it's an asset or whether it's a service account, any of it. It's all identities, and every single one of those identities has one or more entitlements related to its orientation towards and with other assets. And so what that ultimately leads to is, too many privileges probably scattered all over the place. Number two, credentials probably in places you don't want them. And number three, very likely an over-allocation of privileges, because trying to sort of discern how the different cloud providers really describe and sort of allocate the privileges, especially within their own defined policies, is incredibly complicated. It's complex is really what it boils down to. And that complexity at scale, sprawling across more than one cloud, you can see very easily why Gartner made this, prediction saying, hey, look, in the next couple of years, a lot of this is going to boil down to either over-allocation of IAM privileges or to just mismanagement of those IAM privileges. And not because we're not trying, it's because it's hard. So there you go. It's hard, it's complicated, things are moving very fast, things are growing very quickly, and the next thing you know, you've got so much to deal with that it's very easy to miss something, or maybe multiple somethings, especially across thousands of machine identities and millions of entitlements. So that's the beginning. I mean, you really start breaking down the kind of cloud privilege challenges. And, if you go back to the on-prem world, and I always like to start this way. So especially when I teach courses and I'm talking to professionals out in the industry, I like to take that step back. It's really healthy to do it. Take a step back and go, all right, what have we been relying on? And an on-prem model that we can sort of look forward to in the cloud, either coming with us, adapting in some way, or being completely discarded. And when we take a look at privilege management in on-prem models, it's pretty much a different animal altogether. It really is. It doesn't mean that the concepts don't hold. You still want to enforce least privilege. I think the notion of least privilege is always going to be a good one. Finding the right set of privileges to accomplish the goals of production and enterprise efforts, and then enforce that in some way. That's all good, right? I think it's what we've been striving for. But let's face it, it hasn't been easy on premise, and I don't think it necessarily gets easier in cloud, where identity is even more just sort of rampant all over than it ever has been. Now, you couple that with new forms of identity implementation and components. So this is where you start getting into, just not only the privilege policies and roles that are assigned across the spectrum of cloud-based infrastructure and assets. It's also things like cloud-native secrets and keys and other implementation mechanisms that are in place all at once. So you really have this, again, kind of sprawl going on. And what it boils down to for us as security professionals, and I firmly believe this, and I've been saying this for the past couple of years, it's really about time that we start getting a hold of this and looking for a holistic view of entitlements way beyond what you're natively going to get from GCP or Azure or AWS or any of those guys. Now, look, can I go into AWS and run some sort of basic analysis of privileges in use across an account or maybe across something like AWS organizations? Sure, but it's not detailed, and it doesn't really give you any insight into whether those privileges are truthfully the right set of privileges. It's just sort of a snapshot of, okay, here's things that have been seen. You go over into Microsoft Azure with an RBAC and even some of their privileged identity, sort of call outs there. Okay, again, same thing. You get some nice high-level viewpoints or touch points on this stuff, but especially in big, sprawling infrastructure with tons of subscriptions and a variety of different tenancies from here to there and so forth, that is still just nowhere near adequate. Now, Google has some of a little bit better breakdown of some of this stuff, but even then, especially again in large environments, it's just overwhelming. So yeah, of course you can see some things in the cloud, but it's not enough, not on this topic. So this is a great example, and everybody knows this story. So this is the gift that keeps on giving. And I'm actually really, so there's a couple things to say about the Capital One team. First off, okay, it's really unfortunate that this happened. There's no two ways to describe that other than, that's unfortunate because breaches are terrible. But I've met some of the people from Capital One over the course of my journeys in the security and cloud industries, and they're sharp. They're just good. They really have been very skilled and good at managing and building things in the cloud. And that doesn't say that, okay, anybody can make mistakes. Of course they can. But the way I see this breach that occurred with these guys, there's so many just awesome learning points for the security industry to take away from this. I'm certainly not happy that it happened, but I've gotten a lot of insight out of this, and I think a lot of other security professionals have too. These guys had small issues in some of their configurations that ultimately, again, kind of snowballed into what the breach resulted in. But if you go back and look at the sort of key pillars of this breach, first, the attacker that compromised these guys had real experience. She had worked at AWS. She understood the environment. She sort of knew where to look and where to go, and that helps. But if you really kind of look at the vulnerability surfaces and where that threat manifestation was, it was predominantly through sort of a small gap in the armor of Capital One in the form of misconfigured web app firewall rules. And we all, sort of know this story at this point, but that was really only that initial ingress mechanism. Pretty much everything else that unfolded as a result of that had to do with over allocation and just allocation of privileges across the spectrum of their workload infrastructure. And so it was piggybacking on assigned roles, the use of the metadata service in the background to query against that and figure out how they could get the short-term access needed to ultimately get to S3 and pull back those records. But it all boils down to identity. Identity is what I kind of refer to as the glue for infrastructure that you've built in the cloud because it's all software defined. And the fact that the team at Capital One had this problem just tells me any of us can have this problem. And I think it's really been a hard lesson learned, not only for them, but for a lot of enterprise executives and security teams that are really needing to take a hard look at what they have running in the cloud and think about how this is potentially something that could affect them, especially, again, as the attackers are getting more savvy too. So this is not some isolated thing. Attackers are getting up to speed on cloud-based scenarios, technologies, and environments really fast. And what that means for us is that we're not safe just because they haven't found us yet, right? So it's time to really take stock of how privileges are put together in the cloud and really begin drilling down into what that means for us. And this is just an example. This is not to, point fingers at AWS. I could have put a, Azure snapshot up here or a GCP snapshot up here. It's really just one illustration of the different types of services, but every service within the context of the cloud, and they're growing and changing all the time. It's impossible to keep up. But all these different services have their own privilege sets, their own permissions models, their own role allocations that can be created. And what I also tend to find, and again, this isn't to be disparaging or sort of point fingers, a lot of times when people start experimenting with some of these newer technology capabilities, whether that's IoT integration or whether that's machine learning or whether that's, streaming capabilities and services, or content delivery capabilities, or just various storage types, et cetera, et cetera, et cetera. Right? There's so many different elements within these service environments. People usually don't know what they're doing when they start doing it. And so it's more common to see today that people just start building things and getting it up and running and getting it working and then sort of moving on from there versus taking the time to plan out the appropriate least privilege models for the entirety of the infrastructure that they plan on building. It just tends to not really go that way. So kudos to those that are out there and might be taking that approach. But most of the time, in my experience, working with clients, talking to students, it tends to be, let's build something, and then you have something, and then that something becomes a bigger something or set of somethings. And it's sort of tough to rein it in. And as I said, there's just so many services and capabilities now that it just tends to sprawl out of control. And remember, all of these have a variety of different privilege mechanisms and things in place. So I'll give an example of just some research that enforces this. And this came from the folks over at Rhino Security a few years ago. But they sort of went into the stock Amazon. And again, not trying to sort of pick on Amazon, but what they did was they just went in to the Amazon stock privilege models. In other words, the things that are available in IAM within Amazon natively. So things you haven't customized, things you haven't configured. You're just taking stuff out of their catalog of IAM policies and applying them. And they said, okay, let's just take a look at those things and see whether any of those stock policies available from Amazon hypothetically facilitate or enable, things like privilege escalation. So in other words, if I'm an attacker or an insider, or, both, that gains access to a service or an asset within the context of a service that has those native, completely default privilege models assigned, are there permissions inherent in those that could facilitate the user in question, again, the insider, or the, or the attacker to do things that nobody anticipated? And what they found, as I'm sure you guys can all see the ending to this story coming up, they found, yeah, absolutely. There were a number of those just inherently there. And I think that's a great sort of thing to highlight is just, these are default policies. These aren't custom policies. These aren't things that you've gone in and either created from scratch or modified or tuned for your own environment. This is just the stuff that's in their own catalog. And that some of those gave people the ability to modify the policies themselves, to completely change profiles, to go modify and manipulate things like Lambda functions, to pass new roles or privileged roles to other types of DevOps tools. They did a great job of breaking that out. But if you really look at sort of all the things possible within the context of this one cloud scenario, it shouldn't come as a surprise that some of those default or stock policies have a little bit more stashed in there than maybe people realized. And that's likely to be something that continues. So it just underscores the bigger point, which is people are allocating these things to get stuff working. If they can get the default policy from AWS, and there's this sort of native belief out in the industry that, surely AWS is tuning these to be associated in a least privileged fashion. It's a bad assumption, right? Usually the predominant sort of priority here is things that work without like maybe ridiculous over allocation of privilege, but things that work definitely don't always come with the lowest kind of tuned least privilege models in place either. So in other words, again, this is a pretty good example of things in the environment that could potentially sort of rear their ugly head later. And what it means is that we need to start thinking about cloud privilege granularity. Everyone, whether that's a service account and everything, or more of like a machine asset type identity, they don't need the same level of access. You really don't want to start just unilaterally applying policies and role assignments, to just, hey, woo, let's get things working, right? So number one, and most people have started at least coming around to this concept, you really need to be paying attention to how those privileges are being used in the environment. And that, sort of comes down to, at least as a starting point, enabling some forms of identity tracking and logging in the cloud. Now, this is a bright spot, truthfully, in my opinion, in the cloud, because all of the major cloud environments, again, the Googles and Microsofts and certainly Amazons, have kind of a, central logging engine, something like CloudTrail over in AWS, right? Certainly, setting up things like Stackdriver and, feeding that into the logging core engine in GCP, again, those kinds of things, the activity monitoring in Azure. there's definitely a lot there, but that's also the Achilles heel of it, is that there's a lot there. And so, thinking about the idea of wading through millions or maybe even billions of log events, especially for big environments, that's just completely normal. To figure out what those privileged use cases look like can be extraordinarily challenging. And I've actually had some great conversations with security ops teams and investigation teams kind of looking at this, and they know they got to hook up logging. They've got to start sifting through this stuff and trying to figure out what to look for, what the priorities should be, and how to enable playbooks for detection and response from those. But it's not necessarily easy. It takes a lot of work and some dedication. And especially when you start looking at sort of more, narrow use cases for machine identities and the concept of just-in-time privilege requests for human users. So there are cases for administrators or DevOps engineering teams and people that need to go perform some forms of privilege action. Truthfully, those tend to be vastly less than the sort of rote day-to-day standard consistent machine identities or service account identities that are enabling and, again, sort of gluing together all of the components, but they're still there too. And so they're distinct use cases that need or warrant some attention, but just wading through all this stuff is proving to be extraordinarily challenging and difficult for many organizations. You need to expand the privilege controls for cloud, and this is certainly not a complete list. I won't say that this is the entirety of it or comprehensive approach to things, but I'd say, being able to discover the policies and the usage of those policies across everything you got, that kind of discovery effort has to happen first. And then you start looking at these later elements or phases of building out a privilege control solution or type of ongoing process set. And it's got to include managing and protecting those assets and ensuring that they don't change. So especially if you get them to the way you want them, you don't want to see the malicious use of them, and you certainly don't want to see any modification of them. And that means you need monitoring to tell you if any of these kinds of unusual actions happen. You need to have investigative capabilities and, again, playbooks for going in and determining what's going on for response. And then, like day-to-day standard operating procedure, it's more about getting sort of the, state of the environment for auditing and reporting. All of this has to be a part of your privilege control strategy. And doing this for the cloud is not necessarily that simple. So again, going back and looking at cloud logging and asking who can access what, which users and apps have access to sensitive data, who's actually accessing those, being able to go and sort of pull that stuff out is paramount. So not all services are logging the same way. Not all activities get logged with the same way. There's a lot of API references for each individual cloud environment that may or may not be intuitive or well known to the security operators that are involved. That matters as well. And, if you're trying to sort of move in the direction of getting control of your cloud privileges overall, I'd say first, you got to start with that visibility. Number two, you need to be thinking about how you're going to correlate your entitlements to the actual activities that are going on, and basically identify cases where the privileges in use or allocated are excessive. Not easy. Again, it's going to be a really challenging effort. And then, of course, once you figure that out, then you remove those unnecessary entitlements and ensure that they stay in the least privileged condition. As a background step, and not to, kind of go off here, but there's got to be some policies around this too. There's got to be an approach and a strategy. It can't be an ad hoc type of approach. You really need that kind of policy, ideally coming from executive stakeholders as a mandate to say, this is a priority for us, especially as we're moving to more cloud-first orientations, more assets going to cloud, and that's happening, and we all know it's happening. I don't think this should be viewed as a, nice to have or when we get time to do type of activity. It really needs to be top of mind, because otherwise, as I said, I've just seen this get out of hand altogether entirely too often. So with that, hey, I'm going to hand things over to Arik.
Thank you so much, Dave. And thanks everyone for joining us today. So Dave covered quite a lot of the introductory material. So I'll try to be on point and maybe skip a couple of pages that we've already discussed. I'll start with a quick introduction of the company. and the areas we're focused on, and then we'll maybe do a quick demonstration of our platform and try to bring to life some of the points that Dave mentioned in his presentation. Just a quick introduction. Ermetic is a startup company founded early last year. We raised so far close to $30 million. Our latest round with Excel was announced a couple of months back. We have a pretty unique leadership team, 4 founders, all of us very experienced cybersecurity entrepreneurs. We all have been instrumental in building very successful cybersecurity companies before. Our companies were acquired by security giants like Palo Alto Networks, Microsoft. I don't know, many of you probably familiar with the Microsoft ATA or Azure ATP tool. So this was developed by 2 of our co-founders. We're based out of Palo Alto, and we have our development team working out of Tel Aviv, Israel. Now, Dave mentioned that the shift to cloud basically creates an explosion of identities that organizations actually have to manage. And those identities leading to excessive access and overall security chaos that has to be governed. And we've discussed the Capital One breach. Again, it's all about understanding and being able to identify those identities that have all those risky excessive permissions. And it's very important that you have the context within the story. You don't only have to be able to identify those identities that have excessive permissions. Those permissions actually have to be prioritized. Those should be risky permissions. For example, in the Capital One story, this compromised identity had numerous excessive permissions, but only some of those excessive permissions were actually risky, those specifically that granted the identity read-only access across the environment to actually 700 S3 buckets. Those are kind of the AWS storage services. So the fact that those permissions were privileged and allowed this identity to actually access content within those storage services, but also that this permissions were broad enough and affected so many resources across the environment, that would make those permissions risky in our perspective. And this context is extremely important because when you're facing millions and millions of permissions, prioritizing the remediation activities is very important. And there you should be able to start with the most risky permissions, and identifying which permissions are riskier than others is extremely important. And this is where we at Ermetic come into the game. So we have built a platform that allows organizations to govern cloud identity and access. Based on that, we can offer our customer threat protection and also anomaly detection capabilities, all powered by continuous analytics and lots of automation. Again, going back to the story of hundreds of identities, millions and millions of permissions that have to be reviewed and in many cases remediated or removed, this is not a task that could be done manually. Dave was talking about how we should, how we used to do things on-prem and what has changed with the shift from the on-prem world to the cloud realm. So in the on-prem world, many organizations have done periodic, in many cases, manual review of permissions and entitlements. This is something you can do for your users, for your human identities. This is something that was already becoming very challenging to do, even in the on-prem realm for service accounts. But in the cloud, doing that for both human and specifically machine identities becomes virtually impossible because of the rate of deployment, how quickly things are changing in the public cloud, and also because of the scale of the public cloud environments and the millions of permissions you have to address. Doing that manually becomes basically impossible. And this is why we believe at Ermetic that automation is key. It's key in identifying those over permissive identities, prioritizing those identities for remediation, and also doing automatic remediation. Basically, you could call our approach as activity-based IAM. And it's very important when you think about activity-based IAM to differentiate between human and machine identities, because human identities, you could leverage capabilities like just-in-time access provision and so on and so forth. Whereas for machine identity, this is less possible. You also cannot protect machine identities with other mitigating factors like multi-factor authentication. That's why understanding which machine identities are over-provisioned and right-sizing their permissions becomes extremely important. Look at, again, circling back to the Keppel One story, for example. But it's also important to differentiate between third-party access and internal users. I haven't seen a single AWS environment, and again, we're just talking about AWS, but that of course applies to any cloud service provider. But I haven't seen a single organization that didn't have any type of third-party access to their public cloud environment. And there are numerous third parties that connect to organizational AWS accounts. Some of those third parties are like IaaS. There are security vendors that basically connect to those AWS, Azure, or Google Cloud platform environments to provide security value. But those could also include cost optimization vendors. We all know that public cloud tends to be expensive, and many organizations are doing as much as they can to reduce their costs of public cloud, and therefore they leverage vendors, and you know, there are numerous SaaS vendors that help with that basically monitor your public cloud consumption and give you insights how you could optimize the usage of your public cloud. Now, unfortunately, organizations are doing trials with those companies, beta test their products, and then they're just leaving these companies with access to their production environments. And in many cases, I've seen this access being extremely over-provisioned. In some cases, the third parties have full admin access to our customers' environments, which is, of course, mind-blowing, because if one of those third parties is compromised, it's not only that they can access and get out all the information from organizational public cloud environments, but it's even more so. They could actually bring those production environments down with just 2 or 3 command lines, right? So this is very simple in the public cloud environment. You can just bring down all entire VPCs and EC2s and whatnot. So of course, being able to govern third-party access, understand what are the all third parties that have access to your environment, being able to understand what permissions they have, and being able to right-side those permissions is very important. And in your road to less privilege, I would encourage everyone to start first with third parties, then and only then move to our internal users, human or machine alike. In terms of technology, and this is very much specific to Ermetic, we are a SaaS platform. We are API-based. It's an agentless solution. There is nothing to deploy in your public cloud environment. We request metadata access only. We are not going to be the third party through which an attacker can get access to your sensitive data. Our solution is powered by a very sophisticated analytics engine. We support automatic remediation, and we talked about the importance of automation. And of course, we support native CI/CD processes and infrastructure as code, both through our integration and through our RESTful API. I would like to touch maybe on a few select use cases, and then we could maybe switch gears to the demo and see how that actually comes to life in real environments. So we already talked extensively about third-party access and the importance of governing third-party access to your environment. But that does not stop there. Of course, you have to govern user access as well. That could be developers connecting to your environment, administrators connecting to your environment. In many cases, even third-party users that connect to your environment to do some ad hoc work. And in those cases, we would encourage you review those users, make sure that they assign only the right permissions, and also to adopt just-in-time approaches of granting them ad hoc permissions for a limited time frame, and then reviewing those permissions and removing all excessive or risky permissions as well. There are very interesting use cases around acceleration of development. When you think about people that are going to actually use your public cloud environments, those are likely to be developers or DevOps engineers who are measured by their ability to deploy new services and microservices to the production environment rapidly. This is what you basically expect from your dev house, right? If you would task your developers with reviewing the permissions of each identity, role, or user that they're deploying in those production environments, that could very negatively impact the speed of deployment and development of new applications. Dave just showed you the list of all AWS services and mentioned that those services do not necessarily have a very structured or same or a similar authorization schema. So your developers would actually have to understand for each new service they're using how to properly assign permissions to those services, which would basically take lots and lots of time. So you actually don't want to be in that situation where, from a security perspective, you're limiting your developers and you're putting kind of hurdles on their way to deploying new services. The approach that we're advocating for, and we have seen many organizations, innovative organizations, taking that approach. Netflix, for example, is one of those organizations, is basically allowing your developers to push code to production with some predefined sets of permissions that might be a little bit larger than what's actually required and what is aligned with best practices, such as least privilege. But then what you could do, and this is something you could easily do with a tool like Ermetic, is basically monitor all the permissions each identity is using and right-side those permissions and align the permissions each identity has with the actual permissions each identity requires. So you would basically be able to get the best of both worlds. First, your developers would not have to fine-grain the permissions when they're pushing new code to production, or at least to staging environments. They could accelerate their development, while you, as the security personnel, will have the oversight and will be able, after that, right-side those permissions and help your environment achieve the state of least privilege, which is the best practice, without introducing any negative impact on the software development. Of course, understanding who has access to your crown jewel data would allow you to better secure that. This is kind of maybe the first and foremost step. And this is not very easy to do in modern production environments, and they've alluded to that. But again, even if you pick up any, the basic service, let's take S3 for example, the very basic storage service in AWS. If you would take a specific bucket in any AWS account and you would try to ask a simple question like who has access to that bucket, it appears to be a very simple question. In many, in some sense, it's not even a security question per se. It's even a very basic compliance question. Unfortunately, answering this specific question in modern production environments, those that are AWS-based, Azure-based, GCP-based, or in many cases multi-cloud, is extremely challenging, just because there are so many ways you can assign permissions and entitlements in those production environments. And therefore answering that a very simple question, understanding who has access to your crown jewel data and who's actually using that data, is the first basic step on the way to least privilege and on the way to securing your crown jewel data before attackers actually are able to put their hands on your sensitive data. Of course, minimizing permissions and achieving least privilege would allow you to prevent lateral movement. And again, going back to Dave's example of Capital One, this is a clear case where by removing all those excessive permissions, this lateral movement from this compromised web application firewall to the sensitive storages would have been prevented. And of course, by governing user access, you can dramatically reduce the risk of insider threats. And again, those are just a handful of use cases. We see many other interesting use cases with our customers, but I would like maybe to focus first and foremost on those use cases. Now, from here, we can maybe quickly go to the demo and see how those things actually come to life in real environments. So what you can see here is a very simple demo environment. It's not a huge environment. You can see here basically 2 AWS accounts. You can see that they're relatively small. In fact, they have close to 30 users, human users, IAM users, native users, and then there are close to 150 roles. Roles are a specific identities in AWS, similar to what we know in Microsoft environments as service accounts. So roles could be used, for example, by compute resources, machine identities. They could be used by third parties that connect to the AWS environment, or, for example, by federated users. Let's say you don't want to use native AWS IAM users when your developers are connecting to the environment. What you might want to do is to allow single sign-on. So whatever the identity provider you're using, it could be Okta, it could be Azure AD, it could be G Suite, or it could be something else. You want your users to be managed in that identity provider, and when they connect to AWS, to have a single sign-on mechanism in place. In this case, what would happen behind the scenes is that the users would be federated from the identity provider to your AWS environment, and then be granted a specific role that you assign to that single sign-on mechanism. And we'll see an example with Okta in this case. In this environment, we also have close to 170 policies. IAM policies are configurations that basically decide for each identity or resource who can access what in that environment. We have close to 100 compute resources, and you can see a variety of AWS compute resources. So your EC2s, your ECS, EKS, Lambda functions, so serverless, and so on and so forth. And then data resources. You can see here a variety of platform as a service data resources. So DynamoDBs, Glaciers, relational databases, Redshift, and S3 buckets, of course. And then we also provide full visibility to your network resources as well, VPC, security groups, route tables, and so on and so forth. I think the first interesting part can be seen in the style on the left, which is called excessive permissions. And let's maybe spend a couple of seconds discussing that. So you can see that this is not a huge environment. Again, there are a bunch of identities here, close to 150 identities, and a couple of hundreds of resources. Now, across those identities and resources, you're already getting to over 500,000 permissions that are actually enabled. In fact, there are many more permissions that you can assign, or entitlements that you can assign to those identities across those identities and resources, but over 500,000 are enabled. And this is in such a small environment. In real production environments, we see this number going up to millions, tens of millions, in some cases even hundreds of millions of permissions. Of course, reviewing those permissions and understanding which permissions are used, or at least likely to be used, and which ones are excessive is, of course, extremely difficult. And as we discussed that previously, doing that manually is totally out of the question. Fortunately, we have already done that work for you. So we've reviewed all those permissions, and we've analyzed how those permissions have been used in the past. And based on our analytics engine, we are able to make the decision whether each permission is likely or not likely to be used in the future. And if it's not likely or less likely to be used in the future, we would flag that as excessive. You can see that in this environment, we have 90% of these 500,000 permissions. We flag those permissions are as excessive. And this number might look large, but unfortunately, these are the average numbers we see in real life production environments. So organizations would usually have something between 85 to 95 of enabled permissions as excessive. Those permissions could be theoretically removed, and their presence present some risk to the organization, in fact. And this number, at least to me, is mind-blowing, that out of all the permissions that we have assigned, maybe less than 20% are actually required in many cases. Organizations that are getting to something like 75% of excessive permissions are actually those that are doing quite a good job in trying at least to achieve least privilege. Now, of course, it's important to remember that not all permissions are alike. Some permissions, like the one that we had in the Capital One example, where an identity has both a privilege permission, an actual data rate permission, and it also affects the environment broadly. So it has access to hundreds of resources. That permission would be flagged as high severity. And you can see in this example that in the demo that we have 23% of all the permissions are excessive and high severity. Some other permissions might have medium severity, and some permissions might have low severity as well. So this is, of course, very, very important, because when you come to remediate those excessive permissions, this understanding of risk is very important in order to prioritize your work. Because if you now have to remediate close to 500,000 of permissions, it's very important that first and foremost you focus on the high severity ones. Otherwise, you would be spending lots of time doing things that don't really bring effective security to your organization. Now, this is the IAM perspective. Of course, as we all understand, and as highlighted in the Gartner research, most of the security failures are a result of mismanagement of identity and access configurations and entitlement management. But these are not, this is not the only reason. Of course, you have to look beyond IAM to general security misconfigurations. And this is what we are providing with our advanced compliance engine, where we basically scan the environment for general security misconfigurations. Some of those might be related to IAM still. So for example, the usage of a root user or a user not protected with a multi-factor authentication. But that's not all. In some cases, we would also have other misconfigurations. So for example, networking misconfigurations, resources accessible on management ports such as SSH or RDP directly from the internet, and so on and so forth. Of course, you can look and try to understand what are the top accounts at risk. Again, in this specific example, we have only 2 accounts, so this is kind of less of an issue. And also you can see what exactly type of risk we have in the environment and how the number of risks breaks down by the type of risk. From here, I would like maybe to show a few specific use cases. So we can move to the inventory and look at the AWS environment. Now you can see here all types of resources. We have IAM resources, we have compute resources, and so on and so forth. Let's start with highlighting some of the IAM resources. So we've mentioned IAM policies. IAM policies are the configurations that decide who has access to what in your AWS environment. Now, Dave mentioned that a specific type of AWS IAM policies, specifically AWS managed IAM policies, those policies that come pre-configured out of the box and managed by AWS, are unfortunately tend to be extremely over permissive. So in some cases, you might want to use a policy that should grant your compute resource access to an Elasticsearch service, but in fact, without your knowledge, it might actually grant this specific compute resource full access to all S3 buckets in your environment, right? Just because AWS are managing those policies, and they can actually add permissions and entitlements to resources within your environment without you actually knowing that. So organizations have realized that, and some organizations are now trying to move away from AWS managed policies to either customer managed policies and inline policies. Inline policies is a very specific entity in AWS, and it's a policy that is assigned to a specific identity. That could be a role, a user, or a group. Now, of course, when you're trying to achieve less privilege, it's very helpful to use inline policies. Unfortunately, for those of you who are kind of more technical and have experience with AWS, you understand that there is no way you can get a view inline policies to list privilege.
Okay, go ahead.
We try to do some work in helping you identify those, so you can actually easily see all your inline policies in the environment. Maybe just a couple of points. You can look at roles. As we mentioned, roles are identities in your environment that could be used by machine identities or by third parties, it's very easy to identify all third parties that have access to your environment just by filtering on the roles that have a principal as trusted entities, and then immediately you see some roles like, for example, Prisma here that belongs to a security vendor that is connected to your environment. And by clicking on a role, what you can see is this unique view, which we call access graph, that actually shows you the identity, shows you all the configuration policies that are attached to that identity, and you can actually see those specific configurations. And then you can see all the services and resources that this identity has access to through those specific policies. And for each identity, for each resource, like those buckets, you can see exactly which permissions this identity has on each and every one of those buckets, and which of those permissions are used and which are not being used recently. So this allows you immediately see all the third parties that have access to your environment and understand exactly what permissions they have and what permissions they use. You can look, you can filter that on cross-account access, or you can zoom in only on the excessive permissions if you like. So this is the way we allow you basically to govern users and govern third-party access. Now, this identity is, of course, has a risk associated with it because this identity is not active at all and should be removed. But there are many other risks, such as, for example, identities that have excessive permissions. And let us maybe look at one of those. So here is a great example. We have a role that is called admin lambda. It is linked to actually two lambda functions, and when you look at the access graph, you can actually see here this is a role, and you can see that it can be assumed by two different lambda functions in the environment, and you can see what these lambda functions are, and you can see that this role has admin access. You see the administrator access policies, so it grants access to many services. In fact, all 223 AWS services, but you can see that all these red lines indicate that all those permissions are excessive. And in this case, basically, you want to remove all those excessive permissions. And this could be easily done by applying these two very simple remediation steps. Those could be applied manually or applied automatically through our API integration. And you can see here that the work that we're doing, so basically we're taking the existing policy that basically this is the administrator access policy that gives you full access to all the resources in the environment. And what we have done is kind of taken that policy, taken that configuration, and replaced that with a new configuration that aligns the existing permissions, the effective permissions this identity has, to the effective permissions this identity is using. So we've done this kind of second point in Dave's 3 steps to list privilege, where we actually correlating the existing permissions with the actual permissions being used, and that allows us to automatically generate this new configuration, this new access policy that you can easily apply to your environment, and via that process remove the excessive permissions. So in this case, we're able to remove those permissions and limit them only to the EC2 resource. So this is how what we've seen here is how we're able to identify identities that have excessive permissions, how we can prioritize those identities, and how we can automatically remediate excessive permissions in your public cloud environments and help you achieve list privilege, which effectively means pushing this number of 90% to as close to 0 as possible. I think that would be a great place to move to the Q&A.
All right, thanks for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first one is for Dave. Came in while you were presenting. Dave, when you say you've seen cloud privileges get out of hand, what do you mean by that? What is the business impact? Is there mainly a financial impact, security risk, etc.? How could this be quantified?
that's a good question. I mean, saying that they're getting out of hand really means two distinct things. Number one, there are probably more allocated privileges than people realize. So it's just a direct sprawl of privilege allocations and entitlements within the environment, because nobody tends to just unilaterally use one that they've defined or sort of just one from the provider. They tend to tweak and modify and change, and then you have 17 variations of something, and it just kind of goes from there. So I think, from an operational perspective, sure, that's some overhead. That's a cost factor just in terms of reining it in and then tracking and managing that. I think from the security side, it's how those privileges are being used and what those privileges actually are. And the more privileges you have and the more entitlements you have, roles you have, the larger the sprawl of event data that correlates directly back to the use of those privileges, and the harder it might be to sort of specifically get down to what they're doing and why they're doing it. And so in terms of quantification, well, trying to quantify that really depends on the perspective you're taking. Is it event, generation? Is it sheer just numbers of policy definitions or policy allocations? Or does it manifest in the form of incidents or investigations related to those policies or those entitlements that you have to follow up on? And that doesn't even include the obvious scenario where you've had an actual breach or an actual incident, and you've had to do a root cause analysis that tracked back to the use of those privileges in one way or the other, where you would have a completely different set of distinct costs too. So I think there's a lot of things that you could probably look at this through the lens of either operations or security or both, and come up with some quantification around where and how it's probably not ideal.
All right, thank you. This next one is for Arik. What does your analytics engine base its decisions making on? What factors influence those decisions?
So this is a terrific question. So the analytics engine is pretty sophisticated. I'll maybe kind of voice over just a few things that we look at. First of all, we look at the type of the permissions each identity has. We look at the type of the identity itself, whether it's a human identity or a machine identity. We look at the behavior of that identity to determine whether it's a administrator or maybe a developer or maybe a DevOps engineer. We'll look at the type of the machine identity to understand who's actually using that identity. Is it a compute resource within the environment? Is it a third party? Is it maybe the cloud service provider, so AWS or Google itself? And then we look at, as I mentioned, the privilege of the permission. How broadly does it affect the environment? What type of resources does it have access to? And we look at all that information across the environment, across all the identities, and correlate that in real time to drive those decisions and recommendations.
All right, thank you. Can you draw a sketch on how Ermetic would have stopped the exfiltration in the Capital One scenario?
Absolutely. So what we would have done, we would have been able to identify that this specific identity that was compromised, it was a AWS role linked to that AC2. We would have been able to identify that it has numerous permissions and actually high-risk permissions on the environment, and that those permissions or entitlements are not being used and therefore should be removed. We would have helped Capital One to automatically remove all those permissions. So when the web application firewall was compromised and its role was basically seized by the external threat, this role would not have all those permissions to begin with, and the threat would not have been able to access those sensitive S3 buckets in the first place.
All right, well, that's all the time we have for today. Thank you so much, Arik and Dave, for your great presentation, and to Ermetic for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.